Here is a picture with a couple little titles scattered around it. Okay, so if you were a pessimist, what might you see in said image? Maybe you want to be an optimist?
Maybe decaying strawberries, I don't know.
Decaying strawberries. Wow, that's the first time I've heard that one, but that works. Okay. So we've got decay. That works? What's that?
Not a lot of crust.
Okay. Crust. You want crust? Man. So I heard too much crust / sauce.
Strawberries are out of order.
They're out of order? I don't know. I thought they were kind of nicely ordered, but okay. Out of order. Okay. Too big. We'll reference the strawberries. I'm just going to say strawberry.
Strawberry. Not enough strawberries.
Not enough strawberries, so we could just switch this to amount. There's another hand.
It's not that you can't eat.
Okay, can't eat it. Okay, because it's a picture.
I'm hungry, Mike.
Okay, you guys actually come up with some interesting ones. The other ones that I've heard, it's a bunch of calories, right? Okay, too many calories, too much sugar, can't eat that. Okay.
So the fact that calories didn't come up in a room full of nursing majors, I don't know how I feel about that.
So yeah, that's kind of interesting, actually. Yeah, you still need that energy. Optimists.
It's a delicious looking pie, even if you can't eat it.
Uh-oh.
Calories make you happy.
Yep.
Yeah?
Yeah.
Sweet. Delicious. Natural sugars?
Yeah. I'm trying to tell my wife that. Organic.
So I'm going to call out the organic a little bit. What about that makes it look organic to you?
They're whole strawberries as opposed to
Flavored.
Just checking.
I thought you were going like the pesticides field. No, I was waiting on that.
That's why I asked the question.
Yeah.
Okay. We could make an assumption that they were pesticide free. Okay. If you're an optimist, you're probably saying that statement anyway, right? Okay.
there's a lot of it left.
Okay. A lot left. Okay, let's switch it up again. What do you think a scientist sees? Okay. So straight out of the gate, just a strawberry pie. Man, scientists are boring. This is a strawberry pie.
Sugars.
Okay. They might be referencing the sugar. Okay. In particular, we could even use fancy words. We could throw in sugar molecule. Whoa.
What you like?
Sugar particles. I'll work up to spelling molecules. It's 8:30 in the morning.
Is that why you like rolls more than mine?
Yeah. We could look at the weight of it.
How round it is?
Okay. We could look at the roundness of it.
You like circumference?
Yeah, there we go, there we go, there you go.
I was just checking. I wanted to make sure.
I'm not spelling circumference.
Sir.
I appreciate the roundness.
Sounds nice.
Okay. We could look at nutritional value.
How many people it could feed? Just keep cutting it.
Well, I guess it depends on the circumference. Or diameter.
Okay.
Not using that for no, we're not.
You're right.
So-
That's the other LC. Sorry.
We're still looking at the same object, and yet we're using a lot of different words to describe or change how we would describe and look at this. And ultimately, I would say that the scientist is actually making all of these observations. Okay? Every single one, the scientist is putting together and combining. Okay? But a lot of kind of the origin behind this is why are those observations being made? So why would the pessimist reference or use that language to describe the pie? They're pessimists, so we could define what a pessimist was. Okay, we're looking at someone that perhaps looks at the world negatively. Okay, why would the optimist choose those words?
Is it also more positivity?
Okay, they're looking at more of a positive aspect. Why would the scientists use these words?
To describe it?
Okay, why are we describing it? These were all describing it, and you came up with reasons why a pessimist or an optimist would use those words. Why would a scientist use those words?
Logic.
They're,
Because they're trying to not
They
make
can-
the assumptions.
Understanding?
Yep, like a
they can
pessimist
prove, they
optimist
can
would.
prove it.
Interesting ideas. My argument is because they're egomaniacs. What about those words has anything to do with a person's ego? We could argue weight. Yeah, it's an interesting one. I hadn't spun that one. You're right. Why would a scientist use those words as an egomaniac to describe the pie? What is the scientist's reason for making these observations? We could use making them look smarter. I said roundness. You could make the argument that I'm not a very good scientist if I'm using those words. Okay? Okay, but the words we're choosing here aren't necessarily making us look smarter. Okay? Getting at a good idea, though. A scientist sees that and is making these observations with one horrible ulterior motive. I can do it better. That's what a scientist is trying to do. They make observations of the world around them with the presumption that they can do it better. Okay? I'm going to understand why that pie exists and everything about it, such that I can go through and I can do a better job. So that when I then put my pie next to it, everybody thinks that I'm smarter. Okay? We have this egomaniacal drive to do things better. Okay? And sometimes it's just to prove that I know it more. Okay? Which is why when we structure scientists and we structure science classes and we talk about it, we talk about 800 years of science in 16 weeks and we assume that you're just going to figure it out. Why? Well, that other scientist did. Why can't you? Which then does what to your self-esteem about science? Okay? It plummets and you feel like a failure. Okay? What we don't mention is what did that other scientist also do? A bunch of really crappy science. Okay? They failed miserably at making that pie. I can look at this and say, those strawberries, I'm going to bet, didn't come in season from California. They were flown or shipped thousands of miles by boat. They've lost all of their flavor. I'm going to make sure that when I make that strawberry pie, they're going to be freshly picked right out of the ground, plant, whatever you want to call it, put into the pie. Okay? I see that crust, that's probably just a white bread crap crust. I'm going to make a better crust that's going to be more nutritionally valuable because I'm going to make it out of wheat flour. How many people have baked? How good is a wheat crust? Whoops! Okay? So I'm making that change. I'm trying to find what's in it so that I can then adjust it and say, well, does this make it better? Okay? And one of the things that really makes science stand out different, because we arguably do the same thing, is we look at that and we can say, well, I like strawberry pie. I'm going to make my own strawberry pie as opposed to buying it from the store. What makes science ultimately science and not just saying I can do stuff better and being an ultimate egomaniac? One of those crazy, mean, weird people, let's go with that, okay, is that scientists write it down, okay, for a couple reasons. One, we write it down because once I have it written down, what can I do?
Say it's wrong.
Okay, I could go through and say it's wrong. I now have a track record of my failures. I also have a track record of my successes, okay, which is great because now I can publish this new recipe for how to make a pie. And now everybody follows my pie recipe because I'm the greatest pie maker there was. Okay? And I can claim credit for that. But if I don't write it down, it kind of stays with me and it never expands out into the rest of the world. Okay? So not only are scientists egomaniacs, but they also want to make sure that the rest of the generations of life know how awesome they were. Okay? So we have to have that kind of record to publish it and keep it going. Okay, and that's a lot of what we're trying to do, is come up with a process that works so that when we apply it out to different situations, we have a perfect record. Okay? When it comes to the next part, what do scientists do with all of their failures? They hide them from the world. Okay? Because the instant you found out that they failed 90% of the time, what are you going to do? I can do that too. And now there's a competition. Okay? We're defeating against those egomaniacs. Okay? So part of this is recognizing that science hides failures because nobody likes those failures and nobody wants to exclaim them to the world. I would make the argument that what you should be doing through this course is highlighting your failures. Okay? And we'll make kind of an adjustment to that failure. There's two types of failures. Little f failure and capital F failure. Capital F failure we don't want. That's like a grade in the class. I don't want you to be there. What I do want is little f failures. I want you to struggle through the class, find where those failures are, so that when it gets to the time where we test exams or we do final projects, you've already gotten all the little failures out of the way, and now what you've got is this awesome final project and an awesome final grade for the class. Right? That's what we're trying to work through. So when we talk about problem solving in the class, I do expect failures. Okay? I want you to fail on those little things. Okay? I want you to submit imperfect drafts so that we can talk about why they're imperfect and we can fix your writing so that it becomes better. So that when you leave this course, you can sell science to the rest of the world and everybody starts becoming a scientist. We've been too exclusionary as a field and we've lost a lot of brilliant minds because of it. Okay? Everything we're doing is science-based. It's about writing and making everything better. So we want to try and come up with a way to write and prove that notation all the way through. Kind of make sense? Okay. How long did you want to give me, Greg?
How far do we have for the conversation? 5 more minutes?
So the conversation?
To the types of science thing? Or is that?
I think I know what you're talking about.
I was hoping you'd get there, so.
I'm getting there pretty quick.
Okay.
What have we done? 9:40? 45. Okay, I can get there in a couple minutes. Scientific method. So let's go through our scientific method real quickly. We all heard of the scientific method? Okay, for the most part, people have heard of it, right? So we start, okay, as kind of a learning process. The whole point is learning something new with the context that what can we do with that new knowledge? Make something better. Okay? Or ultimately just prove that we are smarter than everybody else by showing that we've learned something new. Okay, and that's all going to start very simply with an observation. Once we have that observation, we do have to keep record of that observation. Okay, so it's all about recording it. So once you have an observation, what might you do in the next step of your scientific method? Okay, write it down. So you now have a written observation, you have a track record. What are you going to do with that information?
Future experiment?
What's going to frame your experiment? We observed that we have a strawberry pie. For me to make it better, what am I going to do? Okay, I'm going to try and make one, but I'm running under the context that I can make it better. So what might I decide? How could I make that pie better?
Create a hypothesis of how you can make it better.
How can I make that pie better? Creating a question, a framing on that. That's our hypothesis. I can make that pie better by sourcing strawberries. Okay? Using better sugar. Instead of just plain white sugar, I'm going to use, totally just blanked on the fancier sugars, but we've got fancier sugars out there. We can just use brown sugar. Brown sugar would work. What's that?
Turbinado sugar.
Turbinado, that's the one I was looking for. Turbinado sugar. You get a better flavor out of it. It's going to make a better pie. Okay? So I come up with a hypothesis. I write that hypothesis down, and now what do I do? I actually test it. I create the experiment. Okay? And here's where the big kind of diverging process happens, in my opinion. What happens as you've been taught the scientific method with experiment? After experiment, what do you get?
Theory.
You get a theory, okay? Or a law. Those are the two things that come out of experiments from your textbook. And that is utter nonsense. Okay? If we're going to look just at a true-false question, so 50% of the time it's right, 50% of the time it's wrong, okay? That statement is false. Okay? Let's make it a multiple choice. 20% of the time it's right, 80% of the time it's wrong. It's still false. What comes after experiment? Utter and miserable failure. Okay? Experiment was wrong. Something happened. So we go back, we create a new hypothesis, okay? Or we fix the flaws in the experiment and we rebuild. Right? Okay, then what do we have? A new experiment. So what do we do with that experiment? What do we get? Failure. What do we get the next time we fix it? Failure. And failure. And failure. And failure. So you wonder why people don't become scientists, is they don't like this concept of failure. Humans just don't enjoy that. Okay? But if you talk to the Nobel Prize winning people, at least nice ones, okay, what they will reference is one time they didn't fail. And that one time they didn't fail was effectively crack. And they got such a rush from having discovered something new that they could contribute out into the world that they went back into the lab to fail again and again and again. Okay? Because that one time that everything worked in alignment, they were able to build out into a scientific theory or a natural law. Okay? That is what science is about. So not only are they egomaniacal in saying that they can do it, they're technically insane. Right? You do the same thing again and again, expecting a different result. That's the definition of insanity. Okay? So scientists have this kind of bizarre egomaniacal nature, and they're pretty darn close to being insane. Go figure, we don't show the failure because everybody's going to call us nuts and ignore the awesome stuff that we do discover at the same time. Okay? So this is one of the reasons why what I want you to do is fail. I want you to see that failure and know that what can happen from that failure is that you can grow and you can become a better person with better knowledge. Okay? It's gonna suck. But at the same time, it's gonna be awesome. But we have to fight through that failure. That's what I'm here for as the chemistry instructor. That's what Greg is here for as the English instructor, to help you fail through those drafts to make awesome final products.
Along those lines, one of the first courses I ever took, I started out as an aerospace engineer and then went to theater performance and production. Then I took 3 years off, and now I'm a writing guy. One of the first courses I ever took was engineering ethics, and then another course on engineering, I think engineering design. And one of the first things we learned about is how ballistic missiles work. They fell thousands of times in very small ways so that they could be very precise at the end. So that's kind of the same thing along those lines. Little F failures that they make adjustments from. I'm off course, okay, correct. I'm off course, okay, correct. I'm off course, okay, correct. Those little F failures we make adjustments from, we grow from. Big F failures end in death. Or end in a mentality that you can't get, they shut you down instead of build you up. Instead of failing, making an adjustment, and growing, little F failure. Big F failures are when you let something become a big F failure, it shuts you down. You don't learn from it, you don't grow from it. So that definition of failure is really important.
Kind of cool? I think it's kind of cool. Okay. So, chemistry's role in this. This is the slide that Greg really wanted me to get to. Okay. Remember how we referenced scientists being egomaniacal jerks? Chemistry's role, okay, we look at the mathematics and physics. So mathematicians go through and play with numbers and make observations about patterns they find in numbers. Okay? Some of those hardcore mathematicians don't care about any application. They're just like, it's cool when I put these numbers together and it does stuff. Okay? Yippee! Okay? My parents were some of those. Okay? We get along great. Physicists came along and said, well, I'm making these observations about the world that I'm seeing around me. Hey, mathematicians, some of that stuff that you're playing with actually makes sense. That pisses off the mathematicians, particularly the ones that are like, I just wanted to play with numbers. Stop making them make sense. That wasn't cool. Okay? So physicists go through and start to make observations of the world and organize and structure the mathematics for us. Okay? Most people have a hard time with mathematics. The physicists are too deeply rooted in mathematics to do anything with it. So what happens? Somebody else needs to come along to be like, dude, this is how it's actually working. Get out of the lab. That's our chemists. The chemists take what's discovered in physics and mathematics and bridge that into the real world. They bridge that across to biology, and you can tell my opinions of most things, and other stuff. So chemists are the bridge, that span the gap of the real world and application and the hardcore kind of just mathematics and science. Which means we dabble in both areas, and we have to be able to bridge that gap. That's pretty huge. Okay? In that gap, we've got a bunch of different stuff being covered. Overall, you start with general chemistry, and then that subdivides out into branches. Organic, biochem, inorganic, physical chemistry, analytical chemistry. There's different ways that we would then lens how we focus on the world. Okay? So chemistry is really there to bridge that gap, to allow the real world to understand the mathematics, and to allow the mathematics and the physics to get applied into the real world. Okay? So when it comes to chemistry, we are the bridge. Okay? We make that gap. If we're weak in chemistry, we can't bridge that gap, and we get two different worlds that can't communicate with each other.
So in truth, chemists are egomaniacal chemical. That's fine. Fine, don't like mine.